In this video, we're going to look more formally at what a solution of a differential equation is and how to use separation of variables. So just remember the definition of solution that we learned back in Algebra 1 is something that we can kind of plug in and make the equation true. The equation needs to be satisfied by values of f and its derivative. So here we're given a differential equation. It involves a second derivative and an original function. And so to be sure that this is the solution, we can plug in these unknown values. So we're going to plug in y right here, and then we still need to find the second derivative. So if I start with this solution, in order to find the second derivative, I just have to differentiate twice. So remember, coefficients drop down. E to the power of x stays e to the power of x. Because that is not just an x, we also must multiply by its derivative, which is -1. So we're just taking the derivative of that exponent. So -1 times 4 is just -4. If we look at then the second derivative, we're going to do the same thing. So this -4 drops down, and this e to some power stays e to whatever that power is, times the derivative of whatever that exponent is, which again is -1. So if I multiply this by -1, it actually becomes +4. So this is the second derivative. And so now I'm just plugging values in to make sure that they satisfy this differential equation. So first we're going to replace y double prime with +4 e to the -x. Then we're going to subtract the original function. So I'm subtracting 4e to the -x. And hopefully that's equal to 0. And you can see that these two terms are exactly the same. Since I'm subtracting, I do get 0 equals 0. And this is, in fact, a solution to this differential equation. So to find a particular solution, remember we're going to look for that value of c. So again, we're going to integrate first. And this step may involve separation of variables. Then, just like before, we're going to use our ordered pair to solve for c. Be careful here, c is a specific value. So if you multiply it by something, you know, it's going to change the value. So you should find c first and then solve for y. So here, this is exactly the same as what we've been doing all year. We're given a derivative. To find that solution, we need to integrate. So we're going to integrate here 3x squared minus 2x with respect to x. When we're done integrating, we will have plus c. So here we'll get x cubed minus x squared. We'll have plus c. And then they are calling this y, so I know that's equal to y. I can then use this ordered pair to go back and find my value of c. So we're not quite done with this, but just for time's sake, we're going to move on to the next exponent. So this is my general solution. I can plug this ordered pair in to find my particular solution. So here we're going to look at now another example of actually using separation of variables. So the key thing is that our variables have to be corresponding. Numbers do not. So when I take this to the other side, I get that dy equals x squared plus 1 all over 3y squared times dx. The only problem is that y squared. So what I'm actually going to do is I'm going to assume there's a 1 in front. So I really have a coefficient of 1/3, and I'm going to leave that where it is. The only thing I'm going to move to the other side is that y squared. And we're going to multiply both sides by y squared, so that we get y squared times dy equals that coefficient of 1/3 times x squared plus 1 times dx. Now this is set up for integration because my variables are corresponding, and this says that y is the only thing allowed on the left and x is the only thing allowed on the right. So when I solve, I'm going to get here 1/3 y cubed equals, remember coefficients can drop down, I'm going to get x cubed times 1/3 plus x. And because this is a general solution, I'm going to have plus c. Finally, when it asks for solution, it is asking for that y value. So I am going to get that y value by itself. I'm going to multiply everything by 3. so that we can cancel that out. So I'll get y cubed. When I multiply by 3 here, that also cancels out. I'm going to have 1/3 x cubed plus x. And then out here, technically, this will be 3 times c. But since this is a general solution, this is some constant. So if I multiply it by 3, it's still just some constant, and I'm never going to find it. So I can leave it like that. And then finally, I'm going to take the cube root of both sides so that I get a solution of all of that. And this is my general solution. If this were a particular solution, I would go back and solve for c up here before I start manipulating it. Okay, now again, here we're just finding the general solution. So instead of writing that as y prime, I'm going to write it as dy dx, just so that we can see our notation. So dy dx minus 3e to the x equals 0. So remember, independent variables need to be on the right. So I'm going to add 3e to the x to both sides so that I get 4y dy dx equals 3e to the power of x. And finally, I'm going to multiply both sides by dx, and I get 4y dy equals 3e to the x dx. Now again, I'm set up really nicely for integration. When I integrate, I'm going to apply that power rule. I'm going to add 1 to my exponent and divide. On the right-hand side, coefficients drop. E to the x stays e to the x, and I get plus c. Again, when it says find the solution, we are going to then isolate the y, and that will give us our solution. And that's it.